Another special method that you shouldn't use is the delete method. Let's say that we created an object here, and in the init method I'm writing that we are initializing this object here. You can provide the delete special method. The delete special method is called when the object is destroyed using the garbage collector. So if you tried here to create three objects, and then let's see what happened in the console, we will get initialization for Mustafa, for Bilal, for Ziyad. And at some point of time, this guy will be deleted, and this guy will be deleted, and this guy will be deleted. So the delete method is mainly called before the deletion of the object. Generally speaking, you shouldn't try to provide the delete method. Otherwise, you have to really be careful. Like there are issues when there are cyclic reference that, as we will know after some time, issues in the inheritance, as we will learn in the next section about inheritance. Overall, this is a risky function to provide. So do not provide unless getting experience with the delete method and the garbage collector. Otherwise, you shouldn't provide it. I'm just teaching it to you for educational purposes. Let me introduce the concept of a memory leak. In programming language like C++, you can create the memory by yourself, but then you have to free it by yourself. If you forgot to clear the memory, this memory will be there in the program as long as the program is running. We call this a memory leak. It is a memory that neither used nor released. And observe that if you have a function that keeps creating memory that you don't release, and the memory is huge, the machine memory will be consumed, and you suddenly will notice that the machine hangs. In Python, we have the garbage collector and other mechanisms that handle the memory for us, and this is a great thing. We learned already about that. We learned about the reference counting and how it is used to do this task. Most of the cases, your Python code itself is good in terms of memory. However, I would like you to observe the following. If you have, in advanced cases, your Python code might be calling another maybe C++ code. If the C++ code itself has a memory leak, your overall application will have a memory leak. This memory leak will not be coming from your Python code itself. Typically, it will be coming from something else. But there is a scenario where you might observe that even your Python code is taking too much memory, and you can notice that in the explorer of the tasks in the operating system, and you don't know why. The reason typically is there are references. Remember, in the reference count in the garbage collector, as long as there are some reference to your object, then the object will not be removed. Sometimes the guys aren't aware of that, and this causes problems. Let's say that you have some dictionary, and for some reason you keep putting objects in this dictionary and you never remove them. What will happen is Python will find that there is reference all the time for these objects. This means that you are using them, and then these objects will never be removed. So if it happened that your Python code itself, it seems to have a memory that is growing up 99%, you have something that is stored in a list or a dictionary and you never cleared, although you don't use it. That's why your program is taking too much memory and seems big. Otherwise, you are using some other external party that is actually have a memory leak. One way to know if you have a memory leak, by the way, is in your Windows Explorer or Linux, open the task management and check out the process of the something. And if you found it, just the memory is increasing and increasing and increasing, you know that there is some memory leak. But this is very informal way. There are some dumping tools to figure out the memory leaks. I would like to teach you about something that is much more problematic in other programming languages than Python itself, although it's in a minor way might be an issue. What we call cyclic references. In simple words, you have two objects if each one of them is looking to the other guy. Here is an example. We have a class A that takes an object B and class B that takes an object from A. And here we created A with none in the begin, then we created B and give it A, and we assign the B to the B of the A to the B. Now A has B and B has A. This cycle is very problematic. Imagine that the program is ending. A reference is 1 and B reference is 1 all the time. Why? because they are referencing each other. So this is very problem, right? Because which one should be deleted? If you are coming from C++, you know that this will cause a memory leak, and we need to use something called weak reference to try to solve this problem. In Python, suppose that the standard garbage collection cannot free such cycle, but Python has some other extra mechanisms that are enabled by default that try to figure out this kind of cycle by themselves. As long as I guess in the very it's also like implementation dependent and such things, but overall I guess Python is doing very well to handle such cycles. So most of the time you don't need to worry about them unless something that's really deep. So 99.9% there will be no problems unless something that's really tricky. Anyway, I wanted at this stage only that you be aware of the cyclic references, but consider it as an advanced concern that you should maybe read in the future. I'm putting here some link about the weak references in Python and their role, and also some future reading links here. Also observe, it's something will not be so helpful, but in case, you can also get the reference count of an object. So the variable a here for example, how many references for it? 2. One reference from here and one reference inside here, so we have 2. When you call the get reference, you will always get 1 plus, like 3 for a, 3 for b. Why? Because the function now itself has an a, so now there are 3a at this moment. That's why I'm subtracting here the 1. The get reference will tell you about how many objects are referencing your object at the moment. As you see, we have here 2 and 2, and this is actually a cycle, but with the modern Python versions, you will notice that the problem, this isn't causing a problem as far as I understand. That's all.